All right, Srini, hope we are ready for the next 20 minutes. Okay, hope you have done your problem. Let's try to solve some of the problem. As I say, we are not going to go to any new topic. We are going to solve the problem. All right, make sure you complete your worksheet before next Friday and send it to me, PDF.
Okay, sir.
Just scan it and then send it to me if you want me to mark. That's your homework.
Okay.
Right? That's your homework. Make a note. You want to do more, go ahead. This one is
Now
number
also you mark teacher.
Structure 1 to 5 and then to number 15.
No, the more question one also you mark teacher.
No need to mark everything. Just the worksheet is good enough already. The others you do yourself and then we will go over your problem. Why want to mark everything?
No. The other one I do, but then say if I don't know that I try, then can you mark teacher?
Then we can go over the class. Why want to mark everything?
Okay.
Worksheet is good enough to evaluate how well you understand. I think you should know how to do it yourself already. Okay. Hope you have tried this question. A police car P with siren on chasing a car T. The frequency of the siren is 100 Hz. The speed of the police car is 30. Speed of the car T is 40. So these are observer moving. The source of sound is moving. What is the apparent frequency of the siren heard by the driver of T? That's the apparent frequency of the reflected heard by the police car. Okay. So two things. One, the observer is you want the apparent frequency of the siren heard by the driver, and after that you want the apparent frequency of the reflected wave. Right? That's the equation. And then it's a better to choose. So what should I do? What is the equation to use? Apparent frequency of siren heard by the driver. Yep. What should I do? First, determine the observer and the police car. Are they moving? Are they in the same direction or in opposite direction? Yep. That's the first thing to decide. Observer and the speed of sound of the police car, are they in the same direction or opposite to each other? Yep. The car is moving away. The police car is chasing. So the sound wave and the observer are moving away from each other. So the first thing to decide, this is negative. Now the source is moving. Right? The source is moving towards the observer. The speed of sound is also moving towards the speed of observer. So both of them are in the same direction. So we choose negative also. Right? Observer and source in the same direction, so we choose negative. Siren and observer. Siren is the source of sound. In the same direction, so we choose negative. Same. Right? Choose negative. For both of them, choose negative. Now put in your value. Speed of sound. And the speed of sound. Observer. Observer is that's the observer. Speed of car T. And then VS, the siren. That one. VS. And that is your frequency. Calculate out. The apparent frequency of reflected wave heard by the police car, police in car P. Right? So you're using the same formula. Now you're looking at there's the observed frequency. There's also the reflected frequency. Reflected wave and observer. Now the observer is the police. Right? The car is the one that reflected it in opposite direction. the reflected wave moving away from the car, going towards the police car. The police car is now the observer, so both are in opposite direction. Okay, so same positive now. Okay, the observer is moving, the source of sound is also moving, but in this case both are positive, right? Because the speed of sound is moving. If you take the car is moving to the right, the police car is moving to the right, so now the source of sound is moving to the right, right? Sound, the car that is reflected the wave is moving to the right, the speed of sound is moving to the left, and the observer is also moving to the right. Observer is moving to the right. The speed of sound is also moving to the left, right? Because now there is the reflected wave. Remember, it's the reflected wave. So add them up, right? This is the frequency now that's being sent by the reflected by the car, and V naught is still the same, right? V naught is observer. Speed of car. Observer is now the police car, and then the speed, the wave source is moving. Right? Remember that you have to readjust your mind. That's why the 40 is now on the bottom there, because the reflected source is now moving. This is the source. Okay. 941. Okay or not?
Yeah.
You must know how to play with the formula. That's the important thing. Okay, make sure you copy. Okay, try number 3. The observer moves with a constant speed along the line joining the two sound sources of frequency 500 Hz. The observer hears beats of 4 Hz. Calculate the speed of the observer. Okay, do that, try that. Right? This one is the observer is moving, and the sound source is stationary, but the frequency of sound source is 500 Hz. And remember that because you are receiving two sound there, right? That's why there's a beat there. Observe, here's a beat of 4 Hz. Calculate the speed of the observer. And how to start? How to start? Right? One is the frequency of the source. One is the observed frequency. That's why there's a beat. Right? For the observer moving towards the sound source, your F1 equals to 500 plus 4. Okay, if you're moving towards the sound source. So F, now you just show the general formula, choose what to use. Right? The source is not moving. So you forget about this Vs, let it be 0. Observer is moving. So the speed is moving to the observer. Observer is moving towards the source. So you choose plus. Both of them are in the same. Both of them are in opposite direction, moving towards each other. Speed of sound or the speed of wavefront and the speed of the observer. Can get the answer?
Yes, sir.
So your F1 is it's a peak 330 V0 observer speed 330 times your 500 100. So you get your 512. Right? I change my F0 to F1. Right? In line with this one. So calculate out. You should get your there's your equation. This one divided by that. Calculate, get that. One there. For the observer away from the sound source, then we get F2 500 minus V0. This is both of them moving towards each other. The observer and the sound source. This is where the observer is moving away from the sound source. We put a negative sign there, just using this formula. Instead of positive, we use negative, that's all. So we get the second equation. So F1 minus F2 is 4 Hz. Right? We know that this one is larger, this one is smaller. So it's 4. Right? That one, F1, that one will go off. Right? The same thing, minus that one. So you still got 152 V0 minus 152 V0. Right? Minus becomes positive. Right? This minus and this minus are positive. You get that? Okay, that 1.32 meter per second. Okay, anything not clear?
Okay, teacher.
Anything you want to ask? Okay, if not, let's do the next one. I think we won't do this one. There's some, no, sorry. Okay, number 4. A car is moving towards a cliff at a speed of 30 meters per second. Sound is horn, which emits a sound wave of 100 Hz, 1000 Hz, sorry. Calculate the apparent frequency of echo heard by the driver. Okay, calculate for me this one. Now your time to try. Right? The car is carrying the horn. So the car and the horn are moving towards the cliff. To calculate the apparent frequency, how to do that? Right? Treat your cliff as the observer. That's the first step. Then after that, treat your cliff. Right? You reflected the sound back. Treat as you become the source now. Right? Frequency of sound on reaching the cliff. Right? That's the apparent frequency F0. Right? Remember, your observer is not moving. So that's the formula we use. Speed of sound is there. The speed of sound. Vs is the observer. The sound source moving, we subtract. Right? It's moving towards the source of the speed of the wavefront. And the car is moving in the same direction towards the cliff. That's why we subtract. Right, we got that. Right, so that is the reflected sound or the echo. There's a frequency there. No more the original frequency, this one. Right, so now the driver of the car, right, driver of the car will receive the observed frequency or current frequency, but the cliff is not moving. Right, so that's why this one is 0. Remember the reflected wave and the observer is the person in the car, are moving towards each other. That's why we take positive. So we are moving towards each other, the wavefront and the observer, it choose positive. And that's your same. That is the speed of sound doesn't change. Observer, that's the observer speed. That frequency now becomes this frequency. And then that V is just there. Okay. Any comment? Anything still not clear?
No.
Okay, that's your homework. Let's try some focus question. That's your homework. Rather than look for you everything and then you don't learn anything. That's your homework. Let's go to focus. Okay, let's go to focus. Let's try some question. Right, as I say, all these things must be in your head. Right, draw your own mind map to help yourself. What are the things you need to remember? Yeah. Okay. A stationary boat emits sonar wave of frequency f to a school of fish which is moving with velocity u towards the boat. The sonar wave is then reflected by the school of fish. If v is the velocity of the sonar wave in water, the frequency of the wave is reflected by the school of fish is okay. What's the answer? You must know the basic, memorize the formula and understand the question. Yep, what equation to use? Yeah, what's the answer?
C.
C, yeah. Right? Remember this formula. Sound wave and fish are moving in opposite direction. Right? Sound wave and fish are moving in opposite direction. The fish is moving towards the boat. Right? And then the sound wave is moving towards the fish, so they are moving in different opposite direction. Frequency received by the fish. Right? That's the frequency received by the fish. We just choose a positive sign there. This is also the reflected wave. This is also the reflected frequency and received by the boat. So now we have to the source of sound. That is the reflected frequency of the fish. Right? You must reorientate your thinking. Now that frequency is a frequency received by the boat. The fish is the one, that one doesn't change. Right? So the source of wave is now changing. Right? That is normal the boat, that is the fish moving towards them. So replace the F1, that one there, into this equation there. So the V and the V will cancel off. So that's the answer. Okay, good. How about number 2? A point source produces a uniform sound in all directions at a distance r from the source. The amplitude of vibration is A. What's the amplitude of vibration at distance 2r from the source? Yep, what's the answer? Ken,
Boy.
what's the answer?
Boy.
Boy, yeah, let's see. Right? Important. I is inversely proportional to R square. I is proportional to amplitude square. So we can combine the two. If you can remember the formula, go ahead. If you cannot, work it out. Take the R square across there. And square root it. AR is constant. Right? That's the new one. That's the old one. So you want new amplitude. Take the R2 down and replace A1, A, R1 is R. Then you got 2R. R and R cancel. Half A. So C. Right? Not B, C. Okay. This one. Variation of displacement with distance from the sound wave which propagate in air at a particular instant is shown in the graph below. Which points have the highest pressure and the lowest pressure at a particular time? Right? Remember your sign convention. Always upwards is positive, to the right is positive, to the left is negative. Either you memorize the answer or work it out. Yep, yep. And then compression, identify which is compression. Compression has high pressure. Rarefaction has the lowest pressure. Yep. What is your answer? Can refer to your note. It's no problem. Know where to find the answer. Don't look at the answer, that's all. You can refer to your note if you forgotten. Yep, yep, yep. What's the answer?
Highest pressure, lowest pressure. A. Answer is A.
Q is a compression. Right? This positive means it's moving to the right. This negative means moving to the left. So all are moving towards the same point Q. So it means this is a compression. This one is moving to the left. This one is moving to the right. So this is a rarefaction. Must be able to identify that. S is a rarefaction. So low pressure. The answer is C. Okay, which of the following phenomena is produced by superposition of sound wave? Yep. Right. Remember superposition, we have two waves. We add them up, get the resultant. Yep. What's the answer? Why take so long? What's the answer? Right? Answer A. Beat is the only one. Echo is the reflected sound. You hear the reflected sound. Doppler effect, you just hear the same source. They don't add up. You just hear the same source. As that is, you see more wavefront, you see shorter wavelength, or you see longer wavelength. That's all. Sonic boom is most likely the short wave, where the speed of the observer or the speed of the source is greater than the speed of sound. Okay. Number 5. One or two more questions, then we'll stop for today. When sound wave propagate in air, two particles that are 0.2 meter apart vibrate in phase. If the speed of sound is 320 meter per second, the frequency of sound wave is. Calculate the wavelength first. Then calculate the frequency. What does antiphase mean? Yeah, Trini, what does antiphase mean?
Antiphase.
Yeah, antiphase, what does it mean? 0 degrees, 90 degrees, or 180 degrees, or 270 degrees, or 360 degrees. Yep, that is essential. You must know first before you can calculate your wavelength. That's why I say you never study. What I teach you 2 weeks ago, you have forgotten already. So nothing in your head. That's why you are struggling. Right? They are 180 degrees out of phase. So it's half a wavelength. That is essential, must know. Right? 180 degrees out of phase, that means one is maximum, the other is minimum. So it's half a wavelength. Half a wavelength is 0.2. So the wavelength, take the 2 across there is 0.4. And the frequency is speed divided by wavelength. Speed is 320, wavelength is 0.4, so it's 800 Hertz. Answer is C. Okay, one last one. I think we have done this already. Unless you are sleeping in class, I don't know. What's the answer? We just did that yesterday. The figure shows a metal wire stretched between 2 points P, T, that's your P, that's your T, which are for X So you can take your P and your T are your nodes. It's not moving at all. It's stationary. 3 small pieces of paper places at position Q, R, and S. When the wire is vibrating at certain frequency, the small piece of paper at R, this one, remain on the wire. This one remain on the wire, but the small piece of paper Q and S drop off. What is the wavelength of the wave which is produced at the wire? Okay, what's the answer? Right, decide whether you want the class next on New Year Day, next Saturday, or you want to take a break.
Okay.
Yeah, what's the answer?
B, teacher.
Say again.
B, boy.
C, boy. No. First, this is a note. This is a note. This is a note. Right? It's not vibrating, so the paper doesn't jump off. Q and S, the paper is thrown off, means it must be vibrating very fast. Antinode, antinode. Right? So it's a complete wavelength from here. It's going up, come down like that. Right? That's how it looks like. So QS are antinode, where the vibration is maximum. PQR, P, R, and T, they are nodes, they are not moving, they are stationary. So the wavelength is just 4x. Answer C. Okay, as I said, Sweeney, you are so far not doing your homework, you're not revising. That's why there is no progress. I have to report to your parent. If you want to carry on with tuition, I'll carry on with you. If you want to withdraw, I'm happy to do that because I say you're not putting in the effort, you're wasting money. You're not putting effort to learn. Okay, I will stop here. Anything you want to ask?
No, teacher. Teacher,
Yeah,
you not tell my mother, please.
no, I already told you already, many times already. I've given you face already. Last week you didn't do homework. This week also didn't do homework. So you don't expect me to keep quiet. You improve your character, then I won't complain anymore. If not, you're wasting money. I will stop here now.
Okay.
Okay, have a good
Merry
weekend.
Christmas, teacher.
Yeah, Merry Christmas to you. God bless.
You celebrate, right, teacher?
Say again?
You celebrate Christmas, right, teacher?
Yes, 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 yes.
Oh, Merry Christmas then, teacher.
Yeah, thank you. God bless you.